Hello students, now we are in the last phase of differential equations. In this form we are dealing with the linear form of differential equations wherein the differential equation, the variables are intertwined and they are implicit in such a way that normal method will not be sufficient to dissociate them. So here we will see that what is the actually linear form of differential equation. So as we know the derivative dy by dx, and then we have plus py is equal to q. This is the linear form of the differential equation. So here what is the p? So here p and q are either variable in x, or constants. So what will happen here? Here p and q may be in form of x or may be constant also, but y variable must be in the denominator. So that is very important here. So what are the steps we are following? We are following, like, firstly we need to find the integrating factor. So what is integrating factor? Integrating factor is to make the function integrable. For this we are multiplying both sides, left hand side and right hand side, with some particular value. That value actually changes the equation into integrable form actually. That's why we say integrable. So basically integrating factor denoted by IF is equal to e raised to the power integral of p of f dx. So we are going to find integrating factor, and after integrating factor we have the directly general solution of the differential equation, and that is nothing but y times integrating factor is equal to integral of integrating factor times q and then dx. So this is the general solution of the given differential equation. Now we have the other format also. So we can see that if in place of dy by dx we have dx by dy, then it would be px plus is equal to q, and here p and q are variable in y, not in x, and it may be constant also. So p and q are either variable in y or constants. Now again we have to see here that x must be in the numerator, it's not be in the denominator. So what will happen here? Again integrating factor we have. So integrating factor IF will be equal to, in this case, e raised to the power integral of p of, and in place of dx it will be dy. So once we found the integrating factor, then our general solution would be x times integrating factor. You remember in the previous case we have y times integrating factor is equal to integral of integrating factor times q and then dy. We will solve this and we will get this general solution of the given differential equation. So now we will take some questions based on this. So let's take this question: dy by dx plus 3y is equal to e raised to the power minus 2x. So in this case, first of all we have to verify whether this is in the form of linear or not. So what is the linear form? We have dy by dx plus py is equal to q. So if you compare this with the given differential equation, we will find that p is equal to 3 and q is equal to e raised to the power minus 2x. So as I mentioned, we have to find the integrating factor, that is nothing but e raised to the power integral of p of dx. So here e raised to the power, in place of p we can put here 3, so 3 dx, and now integration will be e raised to the power 3x. So this is nothing but integrating factor. Now we have to find the general solution of the given differential equation. So the formula is y times integrating factor is equal to integration of integrating factor times q times dx. So that is equal to y times e raised to the power 3x is equal to e raised to the power 3x times q value is e raised to the power minus 2x. So we will put at e raised to the power minus 2x dx. Now we have to solve this integration and we have to put the c as the constant of integration, and this is how we have to solve this question. So is equal to y into e raised to the power 3x, y times e raised to the power 3x is equal to, it will be nothing but 3x minus 2x, so e raised to the power x dx. And finally our answer would be here y times e raised to the power 3x is equal to e raised to the power x will be e raised to the power x only and plus c. Now if you keep e raised to the power 3x both sides, if you divide it, then y is equal to e raised to the power minus 2x plus c times e raised to the power minus 3x. So this is nothing but the general solution of the given differential equation. So this is the approach we are following when the differential equation is given in the form of linear. Now let's take the next example here. Now next question is dy by dx plus 2y is equal to sin x. So same logic we will apply here. So what we will do, our general form is dy by dx plus py is equal to q. So now if you compare with the given differential equation, you will find that p is equal to 2 and q is equal to sin x. Now we have to find the integrating factor, that would be e raised to the power integral of p of dx, that is e raised to the power 2 times dx and then e raised to the power 2x. This is the integrating factor. Now we have to find the general solution of the given differential equation, that is y times integrating factor is equal to integrating factor times q and dx. Now we have to put the value of integrating factor. So y times e raised to the power 2x is equal to e raised to the power 2x and then q is sin x and then dx. Okay, so now we will actually solve this integration. For that we have to apply the eyelet. Eyelet means e stands here for exponential and sin x is trigonometric. This is trigonometric and this is exponential function. So these two we have to consider. So this will be considered as the second part and this is the first part. We are going to apply integration by part. So what is integration by part? Integration by part. So integral of u dot v dx is equal to u times, if this is as a first part and it is second part, so integration of second part minus integration of differentiation of the first part and then again integration of the second part and entire integration. So this is the formula that we are going to apply. So e raised to the power 2x sine x, that we are going to solve. The next slide. So integral of e raised to the power 2x sine x dx, let I is equal to e raised to the power 2x sine x. So this can be equal to sine x and then integration of e raised to the power 2x dx minus integration of differentiation of sine x dx, then integration of e raised to the power 2x dx, and again we have to find the integration of the entire portion. So the next step implies that I is equal to e raised to the power 2x is raised to the power 2x only, and then differentiation of 2x is 2, so it will be divided by 2 times sine x, then minus differentiation of sine x is cos x, so we can write here and here it is power 2x, this will be 1 upon 2, so let it be 1 upon 2 and e raised to the power 2x and then cos x dx. Now what we have to do, we have to write one more times, because next time if you integrate with the same integration by part, then cos x will become sin x and it will be equivalent to the, in fact, the integral given in the very beginning, this one. So next step is I is equal to e raised to the power 2x upon 2 times sin x minus we will take 1 upon 4, 2 2s are 4, e raised to the power 2x and then cos x, and then minus, and minus will be plus, and here integration 1 by 2, so it will be 1 by 4 and e raised to the power 2x sin x dx. So actually one time if you will do, it's a negative, here this is negative, so this portion is negative, so here because of this it will be positive, again if you integrate it will be negative only, but that is the same thing. So in place of this we can consider it I only, so this will go that side, so you can write I plus I upon 4 is equal to, now if you take 4 e raised to the power 2x common upon 4, then within bracket it would be 2 sin x minus cos x, and here it is a 5 upon 4, so I, that is equal to integral of e raised to the power 2x sin x dx, that will be equal to, this is 5 I upon 4, so 4 cancel, so it will be e raised to the power 2x upon 5 and then 2 sin x minus cos x and plus c. So this is the integration that we are going to substitute in the given solution. So e raised to the power x upon 5, 2 sin x minus cos x. So here we can write y times e raised to the power 2x is equal to e raised to the power 2x upon 5, then 2 sin x minus cos x plus c. Now if you see here, what we can find is exactly the same thing here. So e raised to power 2x can be cancelled out. So here if you cancel both sides e raised to power 2x, then the final answer would be y is equal to 1 upon 5 2 sin x minus cos x plus c times e raised to the power minus 2x. So this is nothing but the general solution of the given differential equation. So this is the general solution. In this we found like integration was bit lengthy, otherwise the rule is same for throughout linear form. So we can see this, and now let's talk about the linear plus miscellaneous, wherein we take all sorts of different forms of differential equations and we will solve it here. So let's talk about this question of IIT Advanced. So let the curve y is equal to f of x, the curve is y is equal to f of x, passes through the origin. Origin means 0 comma 0. Here they are asking for the particular solution and satisfies the differential equation. We are given this differential equation. If A and B are randomly chosen from the set S is equal to 1, 2, 3, 4 with replacement, the probability of the above curve passes through A comma B is K, then find 16K. This is the question. So how shall we approach this question? For this, we are given differential equation is dy by dx plus integral of 0 to 5 y times dx is equal to 27. In this, if you see closely, then this is nothing but this is the constant only. Why it is constant? Because if you after integration, if you put the lower limit and the upper limit and you subtract upper limit minus lower limit, exactly you will get some values here. So that is the constant. So if you consider it, so let p is equal to you can write here 0 to 5 y times dx. So the given differential equation will be, therefore dy by dx is nothing but 27 minus p. Okay, and now we have to simply do the cross multiplication and we have to integrate it. So the next step would be dy is equal to 27 minus p times dx. Now we have to integrate. So dy means y only, and here 27 minus p is nothing but constant. So 27 minus p is taken out and we can write x plus c. So this is the general solution of the given differential equation. This is the GS of the given differential equation. Now it's a passing through origin, since it passes through origin. Passes through origin 0 comma 0. So what we can do here, we can put the value in place of x and y coordinates 0 comma 0. Then what will happen? We will find here, if x is equal to 0, y is equal to 0, then c will be equal to 0. Because left hand side 0, right? Then c times 0 times anything is 0. So finally the general solution is, or let's say particular solution in this case. So here particular solution will be y is equal to 27 minus p times x. Now this value we are going to substitute in the given differential equation. So in the previous slide we can see here, in place of this y we can write it. So p is equal to, here p is equal to what? That we has assumed 0 to 5, p 0 to pi, and here it is y dx, y dy. What is written? It is a y dx. So it would be, of course, y dx. Now we have to put the value of y. So implies that p is equal to integral 0 to 5. In place of y, we can put 27 minus p times x dx. So p is equal to 27 minus p upon 2 times x square and 0 to 5. So p is equal to, or you can say 2p is equal to 27 minus p times 25. So 2p is equal to 27 times 25 minus 25p. So 27 plus 2, 27p is equal to 27 into 25, and here we found that 27 is cancelled, therefore p is nothing but 25. So we found it p, that is 25. So in this equation, that is y is equal to 27 minus p. If you put the value of p is 25, here if you are putting the value is 25, this value, then y is equal to 27 minus 25 times x. So y is equal to 2x. So we got this relation, the final differential equation, solution of this differential equation through linear form we got, we got in a normal form, not linear exactly. Y is equal to 2x. So now let's come to the question. Y is equal to 2x. This is the solution of the particular solution of the given differential equation. Now what is saying that A and B are randomly chosen from the set 1, 2, 3, 4 with replacement. The probability that the above curve passes through A comma B. So A and B are nothing but the solution of this given differential equation. If you put x and y, a comma b, then it will satisfy the solution of the given differential equation. So what are the possible values of y? So put x is equal to 1, y will be how much? 2. If you put x is equal to 2, then y will be how much? 4. If you put x is equal to 3, then y will be equal to 6. But in the given set, only 1, 2, 3, 4 is the element. So we cannot consider this one. So we have the only two pairs, 1 comma 2 and 2 comma 4. So 1 comma 2 and 2 comma 4, these are the A comma B actually. So now they are asking for the probability. So from the set of S is equal to 1, 2, 3, 4. So basically for the set of 1, 2, 3, 4, we have a set S. It has the elements 1, 2, 3, 4. And we got the relation y is equal to 2x. This is the particular solution of the given differential equation. Here we found A comma B, that is nothing but 1 comma 2 and 2 comma 4. So they are asking about the probability. So what is the probability basically? So let's see the probability. They are asking that with replacement, the probability of the above curve passes through A comma B is k. So basically it's asking about probability of this event. So k is nothing but here favorable cases, that is 1 and 1, 2 upon total, that is 4 times 4, that would be 16. That would be the sample space of this question. So 2 upon 16 that goes to 1 over 8. Okay, so the value of k is 1 over 2, 1 over 8. Now they are asking to find the value of 16k. So 16k will be nothing, 16 into 1 by 8, 8 to just 16, so 2 is the answer. So here we have to find 16k is 16 times 1 over 8, that is 8 to just 16, we are getting 2. 2 is the answer. So this question we have seen, it was a bit lengthy, tough, but it was very much conceptual question. Now we will see the next question. Now next question is the curve which satisfies the differential equation y cube dy by dx plus x plus y square is equal to 0, which also passes through 1 comma 0. Then we have to find this. So let us see, let me verify the question first. I think there is some problem with the question. Okay, so basically if this is the question, then we are given actually 1 comma 0, that is nothing but we have to put the value of x and y in the general solution of the given differential equation, and here the given differential equation is this much. So if you want to solve this, we have to go for some substitution because normal method will not work here. So you are given differential equation as y cube times dy by dx plus x plus y square is equal to 0. So if you divide both sides by y cube, then what will happen? We will not get it in the form of basically our form will be like this: dy by dx plus x upon y cube plus y cube y square upon y cube y 1 by y is equal to 0. So here if you put like this dy by dx, then we need y variable that should be in the denominator, not the x, because actual form is py is equal to q. Had it been dx by dy, then it's not a problem, then this x can work here. So therefore we have to go for some substitution here. So if you talk about the substitution, we can assume let x plus y square is equal to t. Then what will happen if you differentiate both sides with respect to x? So 1 plus 2y dy by dx is equal to dt by dx. Now the next would be 2y dy by dx is equal to dt upon dx minus 1. So what exactly we want y times? So this conversion will be like this: y square times y. Y square we can derive from here, that is y square is equal to t minus x. So this will be t minus x. So y square y cube, so we can write here y square, so it is t minus x upon 2, then 2 times, you can write here t upon dx minus 1 plus t is equal to 0. So now you have to open the bracket. So it is t into dt upon dx minus t, then it will be minus x times dt upon dx, then plus x is equal then plus 2t is equal to 0. Now if dt upon dx is taken common, so t minus x, and that would be t. So we can write here t minus x times dt upon dx is equal to negative of it will be x plus t. Why x plus t? Minus t and 2t plus t. 2t, that t will go that side, minus t minus x, minus is taken common. So now dt upon dx. So next one would be dt upon dx is equal to, dt upon dx will be equal to x plus t upon x minus t. So let's see here, that would be x plus t upon x minus t. Now this is nothing but in homogeneous form. Let's try it. So divide it, dt upon dx is equal to, it will be 1 plus t upon x upon 1 minus t upon x. We can assume here, let t is equal to Vx. So if you differentiate both sides with respect to x, so it would be dt upon dx. Here it is x basically. So let me erase this portion. Here it is x. So dt upon dx is equal to v plus x dv upon dx. So we can make this substitution. Here t upon x is nothing but v. This substitution also we will do. Only the difference is, in the case of normal linear form, we have the variables x and y, and we are substituting y is equal to x in homogeneous form, sorry, here. So now what is this conversion basically? This conversion will be v plus x dv by dx is equal to 1 plus v upon 1 minus v. So the next step will be x dv by dx is equal to 1 plus v upon 1 minus v. Literally here it is minus v. 1 minus v. So 1 minus v minus v. So it would be how much? 1 plus v minus v minus plus v square upon 1 minus v. Here v and v got cancelled. So what we can write here, x dv by dx is equal to 1 plus v square upon 1 minus v. So now 1 minus v times dv upon 1 plus v square is equal to dx upon x. So we'll go to the next slide now. We have to integrate it, and if you integrate it here, we can write here integral of 1 upon 1 plus v square dv minus v upon 1 plus v square dv is equal to log x plus c. Now let us see here 1 minus v, so v upon 1 plus v square. So here If we will put for substitution, so differentiation of 1 plus v square is 2v. So put it here 2, and to neutralize it, 1 by half here. Now this will be, if you integrate tan inverse v minus half times log 1 plus v square is equal to log x plus c. And now we have to return the value of v. So first of all, let's see what is v. V is nothing but t upon x. So put it in place of v, t upon x. So tan inverse t upon x minus half times log 1 plus t square upon x square is equal to log x plus c. Now again we have to see what is t basically, because t was not given in the question. We made some substitution. So what is exactly t? So t is nothing but x plus y square is equal to t. So x plus y square. So we can write here in place of t x plus y square. So tan inverse x plus y square upon x minus half times log 1 plus x plus y square upon x square is equal to log x plus c. Now if you separate it, although it's not required, but yes, some portion will get cancelled. So tan inverse x plus y square upon x and plus minus log half times log x square plus x plus y square, and minus minus plus, and then x square will be x, so plus log x is equal to log x plus c. So again log x and log x got cancelled. So this is the final answer we have, that is tan inverse x plus y square upon x minus half times log x plus x square plus x plus y square is equal to c. Okay, so this is the general solution of the given differential equation. This is the final answer. This is the general solution of the given differential equation. Now we will go through the next question. This is the last one. This is again IT JEE advanced question. So what the question is given, if y is equal to y of x is the solution of the differential equation. So differential equation is how much? dy by dx plus 1 plus x times x plus y is equal to, here x cube times x plus y whole cube, passes through 0 comma 1. So we have to find the particular solution. Then to find the value of this, so you have to find the GIF, that is greatest integer function, y of 2 plus 2. So this is y of 2 plus 2, and this is the modulus of this. So let's solve this question. For this we have the given differential equation is dy by dx plus 1 plus x times x plus y is equal to x cube times x plus y whole cube. So for these type of questions, we can firstly go for substitution. So what comes to our mind instantly, that is x plus y. So let x plus y is equal to t. So if you differentiate both sides with respect to x, then what will happen? 1 plus dy by dx equal to dt by dx. So what will happen? This 1 plus dy by dx will be substituted with dt by dx. So we can write this dt by dx plus xt and is equal to x cube t cube. Now what shall we do, because we know that if it is t here, because we want t here, so we want t here, then in that case we have to divide this with t cube, then only it is possible. And in that case so suppose we have the general form dy by dx plus py is equal to q. So here t should be here and then tq is there. So we want x cube to be eliminated. We have to eliminate x cube. Or if x is here, if t is here and this t is matching here, then this p and q are the terms of x. So t is here, there shouldn't be any term of t, so we have to remove t. So in the next step we have to write dx. Let me write the repeated statement here. dt by dx plus xt is equal to x cube t cube. Okay, this is the portion here. Now what do you want? I mean, this is your linear form dy by dx plus py is equal to q. It means that this y and this y should be matching and p and q variables in x. So t and t should be here and rest will be variable in x. So it means that we have to divide it by t cube. We don't want here t. So if you divide it, what will happen? dt by dx 1 by t cube, then plus x upon t square is equal to x cube. Okay, so now what do we want? So we have to go for this substitution again. So you can take, let 1 by t square is equal to, you can take it like p. Okay, so if you differentiate with respect to t here, minus 2 upon t cube dt by dx. Actually we have to differentiate both sides with respect to x, so it should be here x. So dt by dx is equal to dp by dx. So it will be here, it will be 1 by 3 1 by t cube dt by dx can be written as minus 1/2 dp by dx. So it would be minus half dp by dx is plus x times p is equal to x cube. Now we change the sign here. So what will happen? dp by dx then minus of 2x, actually we can put this way, and p is equal to 2x cube. This is the differential equation in linear form. So we have to find the integrating factor. is e raised to the power integral of p of dx. So not p here exactly, it would be something different because same notation can't be there. So we can write here directly minus of 2x dx. So it would be e raised to the power minus 2 x square by 2. So it would be e raised to the power minus x square. This is the integrating factor. So we found the integrating factor, then the general solution will be, it will be y times, so here p times integrating factor, that is e raised to power minus x square, is equal to integral of integrating factor e raised to power minus x square and q, that is 2x cube, and dx. We have to integrate it and return the values. So what shall we do? P times e raised to power minus x square is equal to here we can go for substitution method. So let x square be e raised to power minus x square. Here also it will be negative sign, that I actually missed out, because once you change the sign will be negative here. So here also we will have the negative sign. So it is actually q is nothing but minus of 2x cube. Integral of e raised to power minus x square, then minus of 2x cube dx. Implies that p times e raised to the power minus x square. Now this is equal to, we can go for substitution here. So let minus x square is equal to, we can take here t is already taken. Let me see, we have taken t or not previously. T is already taken, y is also taken. So we can take here L, for an example L here. So what will happen, differentiating both sides, minus of 2x dx is equal to dl. It's a dl. But we want here, so one more step I can write here, minus of 2x dx and then x square. So we can write x square times is for minus of x square, and then we will have here minus of 2x dx. So the next step would be p times e raised to power minus x square is equal to, here x square we have assumed here L, minus L, so it would be minus of L e raised to the power L and then dl. Okay, so we have done this, and now we have to go for integration by part. So integration by part, we know the method, u dot v dv is equal to integral of firstly u, then integral of v dv minus integration of differentiation of the first part, integration of the second part, and then dx. So here same logic will work here. So is equal to p times e raised to the power minus of x square is equal to, this is the first term, so let it be first term L, then e raised to the power L minus minus plus, Now integral of differentiation of L is 1, so here it is power L and then plus C. Now we are going to return the value. So first of all we will return L. L is nothing but minus x square. So P times e raised to the power minus x square minus L. L is nothing but here L is nothing but minus x square, so it would be minus minus plus, so it would be x square and e raised to the power L, e raised to power minus x square plus e raised to power minus x square plus c. Now we can cancel e raised to power x square both sides, so here it will be p is equal to x square plus 1 plus c times e raised to the power x square. Still we have to do actually we have to return the value of p again. So p, what is p? Let's see what is p we have assumed in the beginning. So p is nothing but 1 by t square. This is a p. P is nothing but 1 by t square. So we can write here 1 by t square is equal to x square plus 1 plus c into e raised to power 2x e raised to the power x square in fact. Now we have to see what is the value of t again. So t, what you have assumed here, t is x plus y. So this is x plus y, so in place of t we'll put x plus y. So here it would be 1 upon x plus y whole square is equal to x square plus 1 plus c times e raised to the power x square. This is nothing but the general solution of the given differential equations. Now it is passing through a point. That point is given here. So what is the point? Point is passing 0, 1. So x is 0, y 1. So we have to put here x0 and y1. So at x0 and y1, we can put here 1 upon 1. So 1 only, and x0, 1 plus c times e raised to the power x square. That is again 0. This is again 0, so c is equal to 0. So if this portion is 0, we are left with 1 by 1 x plus y square is equal to x square plus 1. So here 1 by x plus y whole square is equal to x square plus 1 plus c times e raised to the power x square. We got c is equal to 0 because we had to put x0 and y is equal to 1. So finally particular solution 1 upon x plus y whole square is equal to x square plus 1. This is the particular solution of the given differential equation. Now in the question what they are asking about y of 2 plus 2. They are asking for y of 2 plus 2 modulus and then it is in the greatest integer. So put x is equal to 2, then what will happen? 1 upon 2 plus y whole square is equal to 2 square plus 1. So 2 plus y whole square is equal to 1 by 5. So if you put here y is nothing but y of 2 basically here. So you can write here y of 2 plus 2, that will be equal to 1 by root 5 modulus. So this value is nothing but 1 by root 5 and under the greatest integer function. So it will take positive value only. So the answer will be 0. So this is how we have completed now the differential equations, and in all its forms, whether from the variable separable to homogeneous to linear, and we have taken so many questions based on this IDJ. So this is, thank you so much. Thank you.